GeoGebra YouTube channel, and in a couple of weeks, and we will post the links for the people. I also encourage everybody to check the GeoGebra YouTube for our previous conference recordings. Now the floor is yours, so you have around 50 minutes, question answers in the end. We are looking forward to your speech. Thank you so much.
No, thank you for the opportunity to present. All right, so let me see if I can get started. Let's see if I can share this. So let me share, minimize this, open my presentation. All right. So I'm hopeful that everyone can see the presentation. Can you confirm that everyone can see the presentation?
Yes.
You see it? Oh, perfect, perfect. So I wanted to start with a which one doesn't belong, which is like a nice way to, get into the presentation, getting like presentation mode. So if you don't mind, take a look at this picture where you're presented with 4 choices. We got upper left, upper right, lower left, lower right. So I want you to take 30 seconds and think about which one does not belong. If you are not familiar with the which one does not belong routine, so the idea is like which one feels like is different, which one feels like is the odd one out. So take it 30 seconds. If you could share it on the chat, I don't know if Sam maybe can help me like manage that, or maybe like in about 30 seconds, share it with the person that is next to you if you are in person. So the prompt is which one does not belong, and of course why. So I'll give you like 20 seconds. Oh, I see something in the chat.
So there are 2 chats. I am not sure if you have access. There's a chat for everybody, and there's chat called questions and answers.
Okay. All right. So I don't know. I think if maybe Sam is able to read some of the responses.
No responses. Not
No responses. Okay. So
you have to ask again.
so the prompt is which one does not belong, which one feels like it's different. We have 4 choices. There is, so I'm going to tell you in advance, there is no right or wrong answer. It's really like, what do you see? What comes to you? Okay, so I got something from Roberto Borda, who said the lower left. Roberto, would you mind sharing why? And then I got somebody saying the brown thing. Brown, okay, so 4 times 4 is 16. They are all similar. I'm just reading out some of the responses that I'm getting, so they're all similar. So yeah, so like the bottom left, it's a triangle versus the other ones have right angles. The upper right, the domino, doesn't have a number 4. So this is a routine that I highly recommend to like start class or like in the middle of class to get students' attention. Is very welcoming. As you can see, everyone can participate and there is no right or wrong answer. I always like to start with something that is like user friendly and everyone feels like they can like chime in and participate. So today, my name is Libo Valencia, and today I'm going to be facilitating MathPlay using GeoGebra Classroom. I'm very happy and excited to be here today. And like, thank you to the organizers for the opportunity to present. So I have been using GeoGebra for quite some time. I'm a big fan. So the goal is today that I'm able to share some of the things that I found helpful, both at home and in school. So first, before we even start into the presentation, I want to thank everyone for being here. Today, I'm off next week. I don't know if that is the case for like many teachers in the audience, but thank you for giving up your time. I feel like only teachers, right, and educators know what it takes. So thank you for being here. You're obviously giving up some time to like hopefully learn something that you could bring back to your classroom that is going to benefit your students. So for that, thank you so much for being here. I really hope that the presentation goes well and that you find some of these ideas helpful and you're able to bring them back to your classroom. Now, I gotta tell you, when I talk about like MathPlay, GeoGebra, I get excited. So I tend to speak fast. So if I'm speaking too fast, let me know in the chat or like let somebody know, and then I'll try to slow down. I'm happy to like go over things a couple of times if necessary. So today's agenda, I know we only have 50 minutes, and I definitely want to leave some time for questions at the end. So today's agenda is that we're going to have a brief introduction. I want to tell you about the idea of like MathPlay, how it came about, how it transitioned from like MathPlay to like teach to at the secondary level at the high school where I teach. And then I want to tell you how I'm using GeoGebra and GeoGebra Classroom to facilitate MathPlay. And then at the end, we'll hopefully have time for some questionings and to connect. So my name is Libo Valencia. I have been a high school educator for the past 14 years. I've taught at different places. I also teach currently both at two different colleges. So I consider myself a passionate teacher. I love mathematics. I love learning and teaching mathematics. I believe that understanding math can help students develop critical thinking skills that can be utilized beyond the math classroom. I also love using different technologies, both to engage my students and to bring math concepts to life. I believe that our students, like the technology comes very natural to them. So it's not something that we should be afraid of, but instead that was something that we should be utilizing in the classroom because it comes so natural to the student, to our students. As an educator, I've taught everything from what you would consider like remedial or essential level algebra classes, all the way up to calculus, both at the high school and the college level. So, so now let me tell you a little bit about like the idea of MathPlay. So, I'm a GeoGebra ambassador. Like the first time I learned about GeoGebra during my undergrad when I was doing my first degree in mathematics. So I learned about GeoGebra and I started using this. At the beginning, it was just as a graphing calculator, but nowadays I'm using it for so much more. So the whole idea of, in addition to being like a teacher, like my most important job is being a dad. I have two little girls at home, an 8-year-old and a 3-year-old. My 3-year-old does whatever she wants, but my 8-year-old seems to listen to me. So the idea of like MathPlay started with my daughter. So as a math educator and somebody who like loves and enjoys mathematics, I started like playing with my daughter. We have all kinds of games dealing with like shapes and numbers and things in our house. So I started like playing with my daughter to like develop this sense of like her passion for like numbers and like patterns and shapes and whatnot. So it was very, we had like so much fun. We will go to the basement and start playing to the point that where my daughter will ask me like, are we gonna play or like math play? So that's where the idea of like MathPlay came about. We started playing. I noticed like different things that when we were like doing MathPlay at home, she was like very happy. She was very engaged. She was very like we did. It never felt like we were doing something that she had to do. It always felt like something that she wanted to do. It was always built about like around like a question or something that we wanted to explore. And we started like very early. This is a recent picture where the problem was like, let's try to make hexagons using like the same number of shapes. So you can see like the first one, there's only one hexagon. And then on this one, we have like 2 and 2. And then on this one, we also have like 2 and 2. Then for this one, we have like 3 and 3. And then for the last one, we have 6 shapes of each. And then we build a hexagon. So like the idea with my daughter was like to facilitate MathPlay in a way that it was like she had sort of like she was in charge. We always did what she wanted to do. It started very early, probably like before like pre-K. She was like probably like 4, I don't know, 3 or 4. And we started like playing at home with like different things with like numbers. So I will give her like a card and like dominoes and say like, okay, let's find numbers that will add up to 9. Or let's find numbers that will add up to 7. And she will like find numbers and I said, all right, now let's do it again. So it was a lot of fun. It always felt like she was engaged, that she wanted to like figure these things out. We started doing like things also with like different shapes. So like one of our like favorite games was like building something in 2 dimensions and then trying to translate it into 3 dimensions, which didn't always work. Like these are 2 like very nice pictures that work out well. But like, of course, like there were sometimes things that didn't work out. And I didn't tell her, like it was hard as her father and a teacher not to tell her like, no, Mariana, that's not going to work. But instead, like let her like figure it out, let her like play, let her see where this is going to go. I noticed that, so from facilitating MathPlay with my daughter for a couple of years, I noticed that she was the most engaged whenever we were exploring something that she wanted to explore. I tried to model like that I don't always have the answers. So sometimes I pretended that I didn't know what was going to happen. And I said, oh, like, I don't know what's going to happen. Let's see, let's find out together. So it always felt that it was like this nice activity that we didn't want to stop. Now, obviously at home, we had a lot of flexibility with the time. There were no grades attached. There were like no other kids in our classroom. So it was just like me and my daughter having fun. But I couldn't, like, as a high school teacher, I couldn't help thinking, okay, like, I wish I could bring like this idea of math play into my classroom, right? At the time I was teaching, so I teach high school, which is like 9 through 12. So it was like algebra, geometry, algebra 2, pre-calc, calc, anything, like all those are the classes that you teach at the high school level. So I wanted to like bring this idea of math play at the high school level, but I wasn't sure how. I'm like, oh my God, is this gonna work? Because at home I have so many advantages with my daughter that when I'm in a classroom with a group of students, it's very different. But long story short, I decided to give it a try. So I decided to give it a shot, you know, give math play a shot with my students at the high school. And GeoGebra was one of the tools that I started to use because it made everything like so easy. So I started with my geometry classes. And what I started doing was, the first time that I did this, we were doing right triangles. So I told my students, all right, guys, so here's what I want you to do. So I did the lesson that I had prepared, or part of the lesson that I had prepared, like my direct instruction. And then for the part where it was time for the students to practice, instead of doing what I had done in the past, which was like a regular like worksheet with like different problems, different case scenarios that I wanted them to explore, I said, I want you to go and take a picture of a right triangle or something that you think is a right triangle. We are then going to upload that picture to GeoGebra and use the tools of GeoGebra to like prove or disprove that we actually have a right triangle. So I'm a classroom teacher. I'm going to be completely honest. I was afraid. I was like nervous. Like, is this going to work? Are they going to do it? Are they going to find a picture? Are they going to like participate or not? But it worked out really well. The students were engaged. They were taking pictures of like things. You could do this at home. They could do it around their house. They could do it in school. So students started taking pictures of like something that they thought was a right triangle. Then we uploaded it to GeoGebra, and then we started like proving or disproving that it was actually a right triangle. So what I learned, similar to what I observed, was that similar to what I did with my daughter, the students were very engaged because they felt that they had some choice, right? In, okay, like I think this is a right triangle. Now my goal is to show that it is or it isn't. But like, I didn't tell them, okay, like I want you to use show that is a right triangle using the Pythagorean theorem or using slopes or measuring the angles. And to my surprise, that's what the students started doing. So students started, like you can see in this picture, they started like measuring the angles. Some of them started like figuring out the slope and say, oh, like because the slopes are negative reciprocals, I have perpendicular lines, which then lead into right angles. So it was very, very nice to see the level of engagement of students, and also that they were applying the mathematics that they knew, like sort of like in a different way, in a different context. Because what ended up happening was that one student used angles, one student used slope, one student used the Pythagorean theorem, and it was nice to see it all together. Now, to be completely like fair and objective, like I didn't get to, like, for example, like students did like one example, or they got to see like their example and somebody else's example. But like in my original plan, like when I've done this in the past, I had a worksheet covering like different case scenarios. So there is like a give and take, right? Because they're not going to do 10 examples, but instead they're going to be able to do one example in depth. What I noticed was that the level of engagement was related to the fact that they got to pick their own picture. So they were working on something that they found around their house or something that they wanted to do. Now, I did this with my geometry students in the context of right triangles, but it could really be done like in different things, right? Like if you want to show that, for example, you're studying like parallel lines. If you're studying like angles formed by parallel lines, like corresponding outer interior, these are things that you could do that are going to bring like a component of like, oh, this is real. This is something that I can apply beyond the classroom to the students. I have also done activities like this, both like at home when we were teaching remotely because of the pandemic, and also like in school where students took a picture of something that they thought it was a parallelogram. And then now that I think I have a picture actually. So later on, students like did a similar activity with parallelograms. So now the problem was, okay, like take a picture of something that you think is a parallelogram and then use the properties that we study in class to actually show, prove or disprove that is a parallelogram. The thing that I want to share from like doing this like many times is that your entire lesson doesn't have to do something that you're just going to go to GeoGebra and do this for 45 minutes. No, like your lesson, like the GeoGebra component could be the activation part of the lesson, like your first 5 to 10 minutes. It could like help you facilitate the direct instruction, or it could be the practice, right? Where the students, you're assessing like, okay, like let's formally assess like what they actually learn, how they're utilizing the mathematics that you're trying to teach them in school. So it doesn't have to be, okay, I have to do an entire lesson on GeoGebra on this topic. No, it could be like a small component of the lesson. And the other thing, like as a teacher, I feel pretty comfortable using like all different kinds of technologies, but I know that people's like level of like comfort is different. So like what I will tell you is sometimes like I'm doing something and things like don't work. I ask my students. My students are like the best tech support that I could ever have because they like it comes natural to them. So like instead of like being afraid, like, oh my God, this is not going to work. What if it doesn't work? What if this happens? What if this doesn't happen? Like utilize your students because your students are the best tech support. So after seeing like experiences some level of like success with my geometry students, I started like using this in like older classes. So I at the time, like the first time that I did this, I was doing conic sessions with my pre-cal students. So I don't know if you're familiar with this, like the Pringles Ringle challenge. So the students like get Pringles and they make a ring out of it. So I saw this and I was like, oh my God, this looks so cool. So I decided to give it a shot with my pre-cal students. So I've done this activity both like as a separate assignment that they do at home, and we have also done it in school. If you're gonna do it in school, bring like extra Pringles because like students are gonna eat them and then they're not gonna have enough to like do the circle. So what I did with my students is like I brought some Pringles, they did the ring, and then right after they did that, because we're studying conic sections, all right, I told them, all right, now let's take a picture, upload it to GeoGebra, and let's find sort of like the equation of best fit for that particular circle. Now, this is like something that happens that I anticipate the first time, but a lot of times, like when students make the circle, it doesn't actually look like a perfect circle. It looks more like an ellipse. So like if you're teaching doing like conic sections, this is like a perfect opportunity, because then it's like, all right, so a circle is not the best fit, but what if we use the equation for an ellipse? So like this is, again, like it promotes collaboration, student work. Students are going to be like, okay, like trying to build a circle. This is also something that you could do within a class period. So my students have done it and they did the rings. I actually recently, now I do it like every year. So they did the ring, they take a picture, they upload it to GeoGebra, and they find the equation of best fit for the circle. So again, I already told them about like conic sections, right? They already know the equation of a circle, but now we're using the knowledge and applied it using some technologies, which is like very engaging for students. Another nice activity that I would do with my students is for my calc students in the context of like within our optimization unit. I had, you do the optimization problem that is a classic where you cut out the corners and then you're trying to build a box that maximizes the volume. So I've done this with students, and I love using like GeoGebra GIFs to like show students, all right, like what is it that we're finding? How come, like, what is this x equals 10 over 3? Like, why is that relevant? Like, what do we, like, I know they could do the math behind it, like, but like, what is it? Like, what does that mean? Like, if I cut a box that is 10 over 3 units, right? Like a square that is 10 over 3 units, what does that really mean? So I found this GIF, courtesy of Vincent, that shows them, okay, like as you cut out the squares, what is happening to the volume and how does that relate to the slope of the tangent line? So at the highest point, slope of the tangent line is going to be 0 because the line is horizontal. That is a maximum. And that's why at that point, we have the maximum volume for this particular box. So like using things like this with like GeoGebra makes it so easy because students can visualize it. Like it brings the math to life and it's like very easy to do. So like with my college students, we had them do this, and then using like a piece of printing paper, I had them like do the box, actually build the box and decorate it. So it was a lot of fun. So at this point, I want to pause because I know I speak fast. I do want to show you. So once students like take the picture, let's say I have a picture in here of a ring that they save. So then what I had them do is, I really love GeoGebra Classic. So I had them go to GeoGebra Classic. And one of the advantages is the students can do this without having like a GeoGebra account. Like, it's really up to them. So like, if your school is going to give you a hard time, oh, we don't want them, they don't need to have an account to be able to use it. So then if you go to plus, right, you want to add an image. I don't want to allow this right now. So I'm going to browse. And then, so like, students build a ring, they took a picture of it, and now they have it saved on their computer. So now I'm going to take that picture and I'm going to put it on GeoGebra. So at this point, students can like, make it big, make it small, like kind of like center around the origin. I like to always go to settings and make it a background image. So now is where the fun begins, because now students have this picture that they created, right, of their work. And now we tell them, all right, so now let's create a picture, or let's create an equation of best fit for this circle. So then students will go in here and say, I don't know, let's say x minus 1 square, and then plus, let's say y minus 1 square. And then let's say that my radius is 4. So then this is not a good circle, but then students can start playing with it, and they can see the relation of like, you could talk about like, oh, what happens as like we move to the left, we move to the right, and what is the radius of the circle? And the students will get like really good at this. So this is just like a very nice application for them to like apply the knowledge that they're doing. And the technology, again, comes so natural to the students that they will do this. They will take pictures of it. They will share it with other students. They will share it on their social media. So like, once we get students to like talk about this and like have this conversation, this math conversation beyond the classroom, like, I feel that we're going to make it more relevant to them. So at this point, I know I get excited sometimes and I speak fast. So at this point, I'd like to pause and give you a chance to ask me any questions. So if you have any questions about the activities or anything that you've seen so far, please let me know. So at this point, what questions do you have? I'm going to take a look at the chat, see if I see any questions. Most of the activities that I've shown are things that you could do within a class period. And again, I don't want you to feel like this is something that you have to do for an entire class period. It could be something that like a part of your lesson. It could be the activation. It could be part of your direct instruction. It could be part of like how you're assessing what students are learning. All right, so now I think it's safe. Oh, wait a second. I see something right now. Thank you. I got not a question, but love the energy. Very nice. Like, we have to, like, I feel, Roberto, that math class should be like everyone's favorite class. Math has the potential to be like everyone's favorite class. So thank you. Thank you for your feedback. All right, so I don't see any older.
Yes, I am here.
Question.
I am here.
Question. Go ahead.
I think there's, I think there's some attendance. Somebody has a question. I don't know if they want to. Please, if you have a question, type it in the questions.
Okay. I saw something, but it was a comment, not a question.
Okay. Okay, wonderful. Thank you so much, Libo, for the presentation.
Wait, no, hold on. Let me. This is the first part. I just like to pause to give people opportunity.
Oh, this is what I was thinking. So this.
No. It's okay. We got. I like to pause. Like I like to build this live and like pause.
Yes. We are so happy to have you here. So you have time. Oh, you will be sending the lesson code.
So I want to show you something else. Yes. So let me do that.
Okay,
so
wonderful.
Let's continue. There you go. So because like I experience like this level of success with my students and I see that they like it, I start thinking, all right, now let's take it to like the next level. So as you know, GeoGebra has a wealth of like resources that are made by a large community. So a lot of times, like, these resources are there. I know that as a teacher, as an educator, we're all like time poor, right? Like, nobody has time to like put something together, but there are like so many resources already in GeoGebra, and GeoGebra makes it so easy and so convenient for teachers to find them. So if you don't have one yet, please make a GeoGebra account where you can like say, so I have a GeoGebra account, and I like to have folders where I like put all the resources that I found. So like for my daughter, for like the colleges where I teach, the different level of classes that I teach, like I have a folder for geometry, I have a folder for algebra 2, I have a folder for calc. So like any resources that I find, I put there and I save them. So I wanted to show you what I'm doing with some of these resources. So I save 4 resources for today, and I want to show you how I'm using them. So my daughter is currently in 2nd grade. So we started using some of these resources from like a very early on. So let's say that you on the search, right, on the search bar, you find something that you like. So I found this resource from John, which is amazing. Like, if kids are learning about money, right, usually, you know, they learn about it and you show them and they have a worksheet. But I had my daughter one day play with this. And what I'm going to show you is, once you find a resource that you like, my advice is like save it into a folder or save it into your account. And then what I want us to do is I want you to experience it as a GeoGebra lesson. And I want to show you some of the advantages of that. So I'm going to make it a GeoGebra lesson. I'm just going to create it. And now at this point, I'd like you to go into geogebra.org/classroom. I'm going to copy the link and put it on the chat. I don't know if that makes it easier, but I'm still going to do it. Wait a second. Where's my chat? Here you go. So I'm going to put it on the chat. I hope everyone can see it. And it's like that easy. You find the resource, which you could just search, and then you go to assign GeoGebra Classroom, and now you have a code. Oh, so I see people are coming in. Very nice. Now, I'm not going to put anybody on the spot, so I'm going to hide the names, right? What I found as an educator is that when you hide the names, when you make it anonymous, students are like more willing to like make a mistake, right? Because then nobody's going to see that you made a mistake. So this resource, that I show you is right here. Let me show you how it worked, but you probably already like that. So you have all the different coins. Let me try to make it a little smaller so we can see the entire screen. So you can start, right? And then what's going to happen is students are going to get an item that in this case is 77 cents. So they're going to start like adding up, right, in the cash register to get to 77 cents. And they could do that in different ways. So when my daughter was first starting to play with this, I will have her show the total so that as she was working on it, so that, okay, like now I got 70, now I'm going to do 75, 76, and 77. And now I'm going to check, right? So very nice. And now you start over. So this makes it so convenient. Like, I wanted my daughter, like, we did like the worksheet that she got in school, and then we started playing with this. And to be honest, like, she didn't want to stop. She just wanted to keep going and going and going and buying things until like afterwards she was like, okay, like, can we try this on your Amazon account? And I was like, no way, no, stop it. This is just a game. We're not going to buy real things. So like when you start doing this, you're going to see that the students, like, it feels like a game, right? Because that's exactly what they're doing. Now, one of the feedback that I get sometimes is like, oh, like, people think that sometimes because we're doing math play is not rigorous math. But like, if you think about it, like using this applet with a class is no different from using a worksheet, except that students is like very engaging. Students want to play with it. They want to do it. And then like, I swear I had to tell my daughter, like, great, stop. Like, we're gonna go upstairs right now. We're done. She gets to play with different things, and it makes it like very convenient, until the point that sometimes my daughter like will tell me she has an iPad. So I see her going on her iPad just to practice. And it doesn't feel like they're doing something because, oh, I'm telling you to do this, but it feels like a game. It feels like she's playing and she's engaged. And right now I can see what everyone's doing. I can see, for example, that student 11 is currently trying to buy this, which is 51 cents. And you can see what they're doing. So it's very convenient also in the sense that, for example, if you have a class of students, right, in front of a device, this will tell you whether or not, like, you might see them in front of a device, but you can actually see what people are doing, right? Right now, you know, I was hiding the names, but I can see what everyone's doing at any given point, which makes it very convenient. And I know that as a teacher, like, you don't have time to like create, you know, reinvent the wheel. This is already done. I did not put together this resource. I gotta thank John, because he put it together, and I got to use it with my students, with my daughter. I actually sent this particular resource to my daughter's teacher in her school, and they were using it in school. So this is something, again, that makes it engaging. It's still rigorous math, right? It's the same idea, it's the same content, and it like, so now that's how I'm using GeoGebra. I found a resource that I like, I turn it into a GeoGebra lesson, right, through GeoGebra Classroom, and then I have my students play and practice. All right, so I wanted to show you a couple more resources, because so this one is for my daughter, again, who's in second grade, but we used this resource before. So another resource that I want to show you, oh my God, this one is so much fun. So this is like a space racing edition. So let me show you. I haven't been able to play like to beat level 5. Maybe you'll be able to do it right now. So I'm sorry if it's lagging a little bit. Let me restart the game. Let me share you this. So let's say that you have students like practicing addition. So let me assign this, make it another GeoGebra lesson. So I'm going to create it. I'm going to try to make the code a little bigger. So now I know you want to keep playing with the thing that you're buying, but now I want you to like experience this one. Once again, I'm going to copy the code. I'm going to go to my chat and I'm going to send it there. There you go. So now everyone should be able to see it. So I want you to play. These are two elementary resources. Oh, also, this is worth mentioning. So I'm licensed in New York to teach secondary. I also teach at the college level. So like the resources that I'm showing you, I'm not an elementary school teacher. Everything that I do at the elementary level is because I've learned with my daughter, or like things that I found that I'm like, oh my God, I'm going to try this with her. And then it turns out that she really likes it. So this is a nice resource because like for like a mental math, it's really good. My daughter really, really enjoys it. Let me go back to my profile. I know you're playing with it. I just want to show you what it looks like. So you get to like begin the race, and then you're trying, there's different levels. Again, I haven't been able to beat level 5. Maybe you'll be able to do it and you can let me know so you can brag. So like they get this, and then like, you know, the spaceship is moving. This is very nice. And again, like things like this are already done in GeoGebra. All you have to do is find it. What I do is always like save it into the folder, you know, for my daughter, or like my geometry folder, my algebra folder. And then I get to use it with students. And let me show you. It's very engaging. Students can practice this all day. And the idea is it doesn't feel like they're doing something that they have to. It feels like it's natural. They're playing, they enjoy it. So like with my daughter at home, this is one that she really, really likes. It has been very good for her mental math because she's able to do it, and she has played different levels. And the other thing that I like and I appreciate is that it has different levels. So like if a student feels like they need more practice, a level 1, like that's fine. They get to pick their own level, right? And then you as the teacher can see how they're progressing. Let me hide the names again. So you can see how people are progressing along, you know, whatever your goal or your objective is for the lesson. You could do this as a practice, maybe at the end of the lesson to see how they're doing. So this is like, these resources are something that I will highly, highly, highly recommend. All right. So because I'm a high school teacher and I also teach college level, I have to show you some resources for like secondary level. So once again, anything that you're looking for, or anything that you're teaching, like look it up on GeoGebra, because chances are somebody at some point made a resource where that you can, that is already there, is already ready for you to use with your students. So I know that Tim and Steve presented already. So they are two people that I'm always like looking out to, right? Like looking for like what resources are they putting together, because they're always putting together really, really amazing stuff. So Tim is I call him a GeoGebra Jedi with Steve. Like they're the GeoGebra Jedis. I'm just like trying to learn, trying to keep up with them. But But this is like a resource, like if your students are learning geometry, right? And they're learning about the sum of the interior angles of a triangle. We have this applet, or like Tim put together this applet about like finding the sum of the interior angles of a triangle, which we know is going to add up to 180. So this is the thing that I'm trying to tell you. Like, instead of giving a worksheet where you give two angles and students have to find the third one, like that's okay. But let's have our students practice in a more interactive way where they can utilize the technology that is at their fingertips. So let me show you this one, because this one is a lot of fun. So again, I did not put together this resource. I found it, I put it on my folder, and then I make it into a lesson. So let me make it into a GeoGebra lesson. I'm going to do create. And now we have something for the secondary level. I'm going to copy the link again, put it on the chat for everyone to join. So now we're joining a geometry lesson. So I'll give people a chance. I'll keep the links open. So if you want to go back and play with your significant other, play with whoever you want, that's fine. It's going to be available. I won't close it. And again, thank you for the people that put this together, because it makes a difference. All right, so now that as you're logging in to this new activity, I told you we were going to do MathPlay. As you log in, so what is the goal in this activity? Goal in this activity is for you to create a triangle. Hold on, give me a second. Now this is too big. So it's for you to create a triangle, right? Angle measures are going to add up to 180. And then the restriction is that you could only use like the digits from 0 to 9 at most once. So now you're having students, like, it's not so easy, right? Because they're just not going to find the missing angle. They have to be, there's like a purpose to it, and they have to be careful in the angles that they select. So I'm going to go back in here and look at my lesson. So let me go back to my GeoGebra profile. I'm sorry about like going back and forth, but this is my lesson. So this is where everyone is right now. And I can see, notice, I can see people's progress. Roberto, I don't mean to put you on the spot, but I can see that Roberto already completed like 1 out of 4, or is currently working on that one. Let me hide the names. And then I can see what different people are doing. So the idea again is for you to come up with a triangle, right? And you want to have the measure. Oh, look at this one. So we got 48, 32, and 90, right? So they're going to add up to 180, and then none of the digits repeat. Now, the other thing that is really cool is if you give out like the same example to all students, they're all going to have the same solution. So I'm not saying that this is going to happen, but it's possible that you have 1 or 2 students that actually figure out how to do the problem, and then you have all the people copying or just like seeing what they did. But when you have something that is more open-ended, like an open middle problem, you could have like different solutions. You can have students, so like students feel like more empowered, right? So, oh, I'm going to try this on my own and see where it takes me. And then like, so this is something that I've done with my students. It works. Students enjoy it. And then there's different levels. You could have them try it again. And it's really like a nice way to practice with like the sum of the interior angles of a triangle. And Tim has all different kinds of resources for like almost anything that you teach. Like go to Tim and Steve, because they probably have something that you could probably use. Now, also, like if you are, like I mentioned before, if you're not so comfortable with technology, here are the things that I want you to think about. Like this is already made, right? You don't have to make it yourself. All you have to do is like click on a sign, make it a GeoGebra lesson, and then have your students enjoy it. Now, some things that I've done in the past, believe it or not, like if I'm going to do something and I don't know if it's going to work, I invite administrators, to be honest. Like I invite my supervisors and I say, oh, I'm going to be trying this, this lesson with this class on this date. Feel free to stop by. It's the first time. Like I want to be like upfront with them and tell them like, oh, I'm going to try this. I don't know what's going to happen, but I'm letting you know, I think it's going to be engaging to students. And then that way, let's say that somebody comes into your classroom, they already know that you're trying something new. And like, if your students see that you're trying to do something for them to engage them, they'll have your back. Like my experience has been that the students will like jump in and try to help you. So like, don't be afraid to try it because of the technology, because you're not comfortable with technology. Don't let that be the reason why you don't want to do something like this. All right, I think I have one more thing that I want to show you. So I should just like keep one open for each one of them. All right, so the last one that I wanted to show you, which I recently did with an algebra class, was like this thing. So like, take a look at how skillful Tim is, right? Like we already know that Tim is a GeoGebra Jedi. So like, take a look at this. Like we're doing interval notation, right? And how it relates to like how like you graph it and what it looks like. So Tim has here like all the possibilities that you can get, including the closed circle, the open circle for like inclusive and not inclusive. And then you're given a problem here. So I got bracket -2, which we know implies that the -4 is inclusive. And then we're going to go up to -2, which is not inclusive. So in my possibilities, I want to have a closed circle at -4 and an open circle at -2. So I'm going to look for that in the possibilities. And I have it. And now I just have to adjust it. So I'm going to go to -4, and then I'm going to go to -2, and then boom, I get immediate feedback. So like, they don't even need Mr. Valencia to go over the shoulder and say, oh, that's right, Johnny. Like, no, everything is there and it's so convenient. So let me show you this one so you can play with it. Once again, I have this resource from Tim, right? It's already made. Now, that being said, if you're more comfortable with GeoGebra, you could take the resource and then maybe add a few questions, or maybe add something that you think is important or relevant to your students, or like to the different levels that you're teaching. So now I'm going to assign this one. I'm going to make it a GeoGebra lesson. I'm going to make it a GeoGebra lesson. And right now we're going to be practicing interval notation. So I'm going to drop once again. This is the last one that I want to show you like this. The link on the chat. And hopefully people will start to log in. There you go. So I want you now to play with interval notation and think about it. Students are going to be exposed to like how many different case scenarios by just by clicking, right? Also, let's say that student is not sure whether or not they're right. The immediate feedback that they get right away is powerful, right? And by facilitating an activity like this, you're activating students as resources for one another. Because like if I'm getting it right, but my partner is getting it wrong, right? I could jump in because I know for sure that I'm getting it right, because I'm getting that feedback from Tim right away anytime I get it correct. So like I feel that this kind of technology could be transformative, right? Because it could be something that students practice at home and they're on their own. I have students say like, oh, Mr. Valencia, remember that day when we did this? Can we open that again? Because I want to practice for the test, or I want to practice for the quiz. So this is something that is there. You don't have to make it yourself. The only thing that you really need is like a GeoGebra account. You assign it into a GeoGebra lesson, and then you just enjoy it. I see that I have a question. So I got a question. In the triangle angle activity, what conclusion should students do? Just about 180. So like, it depends. Yes. So like, it could be something that you could not tell them the conclusion, and then you could have them explore. And then after doing multiple cases, they're going to say, oh, the angles always add up to 180. That could be one possibility, right? If I'm like doing an exploration type of lesson. Also, let's say that you did that part already. The students already know that the angles add up to 180. Now you're kind of like putting this challenge where, okay, we want them to add up to 180, but you can only use the digits from 0 to 9 one time. So like it could go, I feel like it could be different things, right? It could be used for different purposes. As a teacher, I might want it to do an exploration, right? Where students don't know that the angles are going to add up to 180, but after playing with this applet, it's going to become clear, oh, the angles always add up to 180. I hope that answers your question. And if it doesn't, let me know. All right, so I see that people are trying this. And again, you could hide the names or not, is really up to you. And then see what people are doing. I can click on like student 14 and see what they're doing. And this is such an interactive way to practice. I love the immediate feedback. I feel like nowadays, like in 2023, with the technology that we have, a lot of the things that the practice should be engaging to students. And like, if this is the technology that our students are ready to use, we should be facilitating it. All right, I think I have another question. Oh, you're very welcome. I'm glad it was helpful. All right, so let me go back. So I promise you that this 4 lengths, are gonna be kept open. So let me go back. So if you have a GeoGebra account, you can save the resources into whatever folder you have. And once you make it into a lesson, like if you're within your GeoGebra account and you click on profile, I can see like the 4 lessons that I just gave you. I promise you, I'll keep them open, but I can go back to them and see what people are doing. So again, this is a great way for you to practice a lesson, do some exploration, this could be part of your direct instruction because it makes it so concrete, right? The students see what they're doing, they see why they add up to 180. So I strongly recommend facilitating MathPlay through GeoGebra is like the best thing ever. I keep seeing a thing about a question, but I don't see anything else. Sam, if you see any questions, if you're there and you see any questions, let me know. All right, so let me at this point go back to my presentation. All right, so we explored this one, we explored this one, we explored this 4. So at this point, if you have any questions, let me know. Let me know what questions you have. I hope it didn't go too fast. I get excited. Like, who isn't excited to talk about math on a Saturday and GeoGebra? All right, so let me know if you have any questions.
I don't see question. I see the comment that thank you very much.
Oh, nice.
Oh, how to make infinity? Somebody's asking how to make infinity.
Oh, how to make infinity. I'm assuming that is, hold on, let me go back to the applet. So I believe, so if you're going to infinity, oh, that's a good, so I think within the possibility, let me see, let me try to, okay, so here we go. So here's a problem dealing with infinity. So I want, as you move this, the possibility sector, you'll get all the different options. So in this case, I'm coming from infinity. I want the 1 to be inclusive. I want the 6 also to be inclusive. I think it's this one, right? So I want, so to answer the question, how do you get infinity? Move the possibility sector until it matches the one you want. So I'm gonna go to -1, and then this one is gonna start at 6. I hope that answers your question. So if the inequality gave you infinity, move the possibility sector until you get the line going all the way to the left or going all the way to the right. So I know let me see if that, okay. Ellen, I hope that answered your question about infinity. And then the last thing that I wanted to mention was that, so I'm pretty active on Twitter. You could find me at Mr. Valencia 24. I have a book called MathPlay coming out later this year, so stay tuned. I'll be posting and updating via Twitter. So like anytime I found a helpful activity or something that works well with my students, I share it on Twitter. I also have a YouTube channel where I've shared some resources and some past presentations. I have a presentation for the GeoGebra conference, the Florida GeoGebra conference last year, and I believe that this one is going to be there in a couple of weeks. So at this point, thank you so much. I'm sorry if I speak too fast, but I get excited. So thank you so much for being here. Thank you so much to the organizers for the opportunity to present. I really hope that this was helpful and that you can take some of these ideas, bring them to your classroom, and have students your students MathPlay through GeoGebra.